All right, so let's take a look at, I could start off with like the announcement thing. Good morning. No, never mind. Okay, sorry. All right, so we agreed on our stuff that we are going to skip number 1. Did everyone skip number 1? Good. All right, you skip that. All right, so for number 2, okay, this is my 6th hour. 6th hour for this one. All right, so now there was one typo thing right here, so it should be a parallel symbol. And we said in our notes this would go along with page 25, right? So everyone has out page 25 right now open. Page 25 right now open. Yeah. And we're looking at our notes that we did for this. Okay, let's see if we paid attention. Class. Yes. What is the first thing in a 2-column proof? Thank you. All right, so let's take a look. For right here, excuse me, pay attention. All right, it says 1 is congruent to 3, so I'm going to mark that. 1 is congruent to 3. 2 is congruent to 4. Very good. So corresponding angles. Does this look a whole lot like we did before? Yeah. Okay. So my answer is corresponding angles right there. All right. Next one. It says that triangle WMK, the big one, is similar to triangle WPY. WPY. What information is given here and here? Angle, angle, right? So angle, angle. I have 2 angles, so my reason for that is angle, angle, similarity. Looking at your notes, find the statement that looks like that. What's the reason for that? It's in your notes.
Wait, which one for number 4?
Number 4. Very good. Definition of similarity. Definition of similarity. Now, for this next one, looking at your notes. Very good. Segment addition postulate. Number 6. There we go. Number 7.
Subtraction property of equality.
Wow. It's almost like I gave you the exact same thing in the notes.
Wow.
Why would I do something like that?
Wow.
Oh, and I'm hoping that no one gets this wrong.
Oh, man.
Did I just hear a challenge accepted? Seriously? Did I hear that? Come on now. Anyway, all right. Okay. I told you guys what page this is in the notes. So 20 and 21.
Because I knew he was going to ask.
Wow, excellent. See? It's amazing what happens when you hear it. You learn something.
Over and over.
Yeah, hey, for a reason. On an occasion, people actually pay attention and remember it. So, on number 3, it's asking, 5 cities are located various distances apart as shown below. A, B, C, D, and E. So, from here, are the 2 triangles similar? Okay, so we have to prove a similarity here first. What shape do I have here? An X. So what does that give me? Very good. Vertical angles, right? So I'm going to have a vertical angle here. And it should be congruent to here, right?
Yeah.
Yeah. Vertical angles. Alright, so now I have sides, don't I? I have sides. So the sides have to have the same
Ratio.
scale factor, ratio, proportion, right? Very good, yes. So I always start with the smallest one because that helps me out. So if I'm going to start with 80, what corresponds with 80? 120, right? So if that means that these two have to go together. So I'm going to do 80 over 120 because these two are my corresponding, and you are going to reduce that fraction and give me the scale factor or proportion, and you would tell me that it is
2/3.
2/3. Make sense? Okay, so now I did 80 over 120. Now I got to check the other one. So the other one's going to be,
2/3.
100 over 100.
thank you, 100 over 150. That reduces to 2/3. Very good. Now, do they have the same proportion? Do they have the included angle?
Yeah.
So are these two triangles similar?
Yes.
How?
Angle.
Not angle, angle, because these are not angles. These are,
Side.
so this is going to be what?
Side.
Side angle side, right? And side angle side. Very good.
Oh my God.
Are they similar? Yes. Side angle side similarity. SAS. So we have side angle side similarity. And now, okay, so similarity, find the distance between for A and B. So for the segment AB, do I know that? Say no.
No.
Okay, what do I put there if that's something I'm looking for?
X.
I'm going to put an X there. Very good.
8 equals 240.
So, wow. Oh,
Well, I did it all yesterday, and
Good
I
job.
thought that's not how you did it because you did it differently. So I was like, I did it all.
okay, your answer's still the same. You okay? I know, man. Okay. Anyway, all right, start with the comparison that I know. I need corresponding sides of two values that are not the variable. Someone said 80 over 120, right?
Yeah.
Okay, so 80 over 120. So 80 over 120 is equal to, I need to do the next one.
X over 360.
Very good. X over 360. 80 over 120 equals X over 360. So that set up my proportion so I can do my cross products to solve for X. And then I do this, so it's going to be 120 X equals 80 times 360. What do we get?
28800.
28800, like that?
Yep.
Ooh, good. Divide both sides by?
120.
Very good. X is, I heard it,
240.
240 what?
Miles.
Miles. All my units over here are in miles, so therefore those units are in miles. ¿Está muy fácil?
Yeah.
Sí.
And this.
Hey, if you know what you do. If you don't know what to do, then you gotta learn.
Exactly.
No aprendí nada.
He's so confused. Did you learn that on your telenovelas?
No, because they just said que hora es all the time. So I was like, all right.
He said you didn't learn it.
You're right, I didn't. Oh, he didn't? Oh, that was the translation. All right,
But
so
the
now,
same to you.
do you like what I did over here?
está hablando a ti?
No, I'm just kidding.
Oh, wow, seriously? Did someone just call him a donkey? Wow, okay. Can't we all just go on? Donkey means donkey in the same English and Spanish.
Donkey means dog.
Don't keep on.
A burro is a donkey.
A burro?
Man, you go to Postulate and get a burro bowl, don't you?
To what?
Anyway.
How did you say Chipotle?
You need to watch more television.
Watch more
Oh, yeah,
television.
watch
Okay, you ready? So, for this one right here, I'm going to draw a picture off to the side, because, I don't know, I want to draw a bigger picture here. Okay, Jose wants to find the height of a building, blah. Alright, Jose is standing 15 feet away from a tree. The tree is 12 feet tall. The tree is 26 feet away from the building. Alright, so, I'm going to start right here. So, I'm going to draw my building. Okay, so I have a building, and then I'm gonna draw a tree. Okay, I'm gonna, you know, what's his name? Who's the guy that draws the happy trees? Not me, right? Bob Ross. Yeah, there we go. So, yeah, I know. Too soon, right? Too soon. Okay.
Is he dead?
Yes. Yeah. Anyway, so I'm gonna Bob Ross this tree. I'm gonna draw a happy tree there. Okay. Okay. Anyway, so I'm gonna pretend like I am not getting shade all over this.
Mister, are you recording this?
Yes, I am, and that makes me worse.
Oh
my God. See, this is like teacher abuse. Oh my.
It's the love.
My students abuse me. All right. Anyway.
We ain't throwing stuff.
All right. So we have the person, Postulate, over here. So, and here he's drawing. Look, he's wearing a hat too.
Why does he have to be Jose?
I don't know, because it says it's Jose.
Okay.
Right? All right. So, this is what everything is actually meaning from those words. So the tree is 26 feet away from the building. 26 goes here. He is 15 feet away from the tree. So there's 15 right here. Hey. Please.
He's recording.
And the tree is 12 feet tall. And I'm looking for the height of the building. So I'm going to put an X right here. And I know your guys' drawing skills better be better than mine.
Not me.
So if I was to look at this, in the big triangle right here, what is this value down here?
The value.
It's not the valley, I said value. What is the number? Give a numerical value for the distance from here to here. 41, thank you, with less sarcasm. Okay, so we have 41 here. Do you guys see how I got 41? Because it's from here to here is 15, here to here is 26, so the total is 41. Yes, what that guy said. Now, I'm going to look at it as two separate triangles. Looking at it from two separate triangles, let's start with the bottom of here. So I'm going to go 15 over, now, this is a small triangle, so the bottom of the small triangle is 15, so that corresponds with what?
41.
41, very good, because that's the bottom of the big triangle. 41 equals, I would put 12, because that's the small triangle, over, very good. 12 over x, do my cross products, I come up with 15x is some number. Please multiply that for me. What'd you say it is? 492. So 492. Divide both sides by 15, right?
Yeah.
Yeah. X is going to be about a boot, because it says round to the nearest foot. So you're going to give me what?
Decimal?
No, round it to the nearest foot. What'd you come up with? 492 divided by 15. I know you guys are working on this, right? So can someone please? Joseph, save me, help.
33.
33. Right? Did I lose everyone there for a minute? Because all of a sudden no one wanted to say anything.
I got the wrong answer.
Okay, but did you do this right here? Or are you changing it? Okay.
Yeah, I got it right this time.
Okay, good. Now, listen. For this problem right here in the book, or not in the book, in the test coming up, you actually got the shape drawn for you. I think the hardest thing that a lot of people are going to have with this is just drawing it, but then on the test you have the shape already drawn for you.
I drew it wrong and I did it wrong.
Okay, so like I said, the hardest part, drawing the shape.
Why is that the hard? Like all of that higher numbers.
What do you mean? The numbers are not the same, and so you would have to read through and plug in information from there. So, all right, let's see. Let's take a look at, so draw a picture. We had that. Oh, are the two triangles similar? And I'm going to tell you,
Yeah.
yes. Now, do they both share this angle where Josue is, or Jose?
Yes.
They share that, so that's going to be a reflexive angle, right?
Yeah.
And whenever I'm dealing with these type of problems, they're always what type of triangles?
Right.
Very good. Right triangles. Because they share this and they're both right triangles, that means that these are going to be similar by how?
Angle.
Very good. So angle, angle, similarity, and it's going to be about 33 feet. Okay, so let's take a look at number 5, and I got this one down pretty good. So on 5, I don't like the way that they asked to write 4 different versions of this. Please tell me on the test it's not like that. I'm not even asking you that, but still, it's. Nope, you don't have to write 4 different ways. Nope, let's just solve it one way. So, what are we trying to find here? Where is the x going to go on number 5?
On the
On the right. Left side?
On the flagpole, right?
Yeah.
Yes, that's supposed to be a flagpole, so this is where my x is going to go. Now, if I was taking a look at my practice, doesn't this one match number 3, the dinosaur problem?
Yeah.
Yee, right? Good.
Yeah.
Let's set it up. So how would I set up this problem? Someone.
5
5
over x.
over x equals
13
13
over 46.
over 46. There is 4 different ways to try and solve for this, to set up your problem. That is one of them. If you set it up the same thing, or something similar, you should come up with the same answer. I could have done 13 over 46 equals 5 over x. I could have did, I don't know, just different combinations.
Yeah.
So either way, you're going to get 13x. So if I solve for this, it's going to 13x equals 5 times 46, 230. I think so.
Yeah.
Okay, divide by 13. X is,
18. Well,
Okay.
are we rounding or
yeah, it's going to be rounding because it says right here to the nearest tenth of a foot. So there's a boot. A boot. So it is going to be 18 feet. Because it comes out to be like 17.7 blah blah blah. 7 blah 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 blah. Okay, and so it rounds up to 18 feet for this one. Jess? Jess.
Sure.
Wait, what number 8?
C? No, this only has a part B.
Oh.
No, we're not on C yet. It doesn't have C. Alrighty. Let's take a look at here. Given the diagram below, I told you this matched one of my problems on page 8 and 9, right? I gave you a page number for this. So, first, let's see if they're going to be similar. If they're going to be similar, are my angles the same?
Yeah.
Okay, so let's go ahead and do that. Let's mark that. That one is congruent to that one, right?
Yeah.
So if they're similar, the sides have to have the same ratio or,
Scale factor.
thank you, ratio or scale factor. Okay, so now for that, it's going to be, I'm going to start this out. I'm going to start with 8 over 12, very good. Reduce that. 2 over 3. Okay, so now that was 8 over 12. Now let's do the other one. 12 over 15. And what do we get there? 4/5. Okay. So now, are these two triangles similar? No! Exclamation point. Now why?
The scale factors are different.
Oh, very good. Scale factors are different. Very good. It's a very good way of saying it. They're not similar. Yes. Yes. Alrighty then, and so that leads me up to question number 7 and 8. I'm going to work on those ones tomorrow. I'm going to give you guys the rest of the time to try and work on your notebook. So don't forget, like and subscribe. And if we get up to 100 views, Master's going to do a dance.